Okay, 2.6, college algebra. This is our review for the upcoming quiz on inequalities. So everything has to do with inequalities. So if we look at the first one, this is a simple inequality. It only has one inequality sign. Treat it just like you do equations. Gather the x's on one side, the numbers on the other. So I've got 11x plus 10 less than or equal to 54. I will subtract 10 from both sides. And that's when I get 11x less than or equal to 44. I divide both sides by 11, and that gives me x less than or equal to 4. Okay, your answer is interval notation. If you need a number line, that can help you. So x is less than or equal to 4. Closed circle, shade to the left. Okay, so that is the interval from negative infinity to 4. So the answer to this is negative infinity to 4, parentheses around negative infinity, and a square bracket around the 4. Next, we see a compound inequality. So you treat this as two separate problems. So if I add 3 to both sides in this first one, I get 13x less than or equal to minus 26. If I divide both sides by 13, I get x less than or equal to negative 2. Then if I look at the other inequality here, if I add 8 to both sides, I get 2x is greater than 2. And then I divide both sides by 2. And I get x is greater than 2. So I've got two conditions here, x less than or equal to negative 2, x greater than 2. So on a number line, negative 2 and 2. What does it mean to be less than or equal to negative 2? That means closed circle, shade to the left. What does it mean to be greater than 2? That means open circle, shade to the right. What I see here are two intervals, okay? What are those two intervals? Those intervals are from negative infinity to negative 2. And then to join them, there's just a union sign, 2 to infinity. And that is my answer. Okay, negative infinity to negative 2. And then 2 to infinity with the correct enclosures. This next one, you're going to break into two problems. Negative 49 less than 1 plus 10x, and 1 plus 10x less than negative 29. And to solve this, I'm going to subtract 1 from both sides, and I get negative 50 is less than 10x. I would divide both sides by 10, and I get negative 5 less than x. Another way of writing this is x greater than negative 5. So you just read this negative 5 less than x, read it from right to left, okay? Now let's look at the next one. For this one, I subtract 1 from both sides, and I get 10x is less than negative 30. Divides both sides by 10. X is less than negative 3. Okay. So on a number line, negative 5 is the smallest number, negative 3 is the larger number. Numbers that are greater than negative 5, that's this direction. Numbers that are less than negative 3. So I see one interval there. This answer is negative 5, negative 3. That's the answer for problem number 3. And let me try to create a little bit of space here. Okay, so let's look at the next one. 2 minus 5x greater than or equal to 27. Okay, simple inequality. If I subtract 2 from both sides, I get negative 5x greater than or equal to 27 minus 2 is 25. Divide both sides by negative 5, knowing that when I do that, I've got to change that inequality. So I get x less than or equal to -5. On a number line, -5. What does it mean to be less than or equal to? That's this direction. So this is negative infinity to -5 with a bracket around the -5. Number 5, absolute value. We're taught to break these into two separate problems, okay? First problem, write down everything just like you have it without the absolute value. Second problem, 5x minus 10, make two changes. That less than or equal to becomes a greater than or equal to. That 30 becomes a -30. Now let's solve both sides. So in order to solve this, I add 10 to both sides of this equation, and I get 5x less than or equal to 40, and that gives me x is less than or equal to, when I divide both sides by 5, 8. And the problem here, add 10 to both sides, and I get 5x greater than or equal to minus 20. Divide both sides by 5, and I get x greater than or equal to -4. So on a number line, -4 is the smaller of those two numbers. What does it mean to be greater than or equal to -4? That's this. What does it mean to be less than or equal to 8? That's this. There is one interval for this answer, -4 to 8. Close brackets around both of them. Number 6, your goal is this absolute value thing has to be isolated. Okay, so I've got 2, 3 plus 8x greater than 10. Okay, if I need this to be by itself, I need what's in this absolute value sign to be by itself. What's keeping it from being by itself? It is multiplied by 2. So I will divide it by 2. So divide everything on both sides by 2, and that gives me 3 plus 8x, absolute value, is greater than 5. Now I can break this into two separate problems. First problem, copy down everything you see. So that's 3 plus 8x greater than 5. Second problem, 3 plus 8x less than -5. Now let's solve both of these problems. Subtract 3. You get 8x is greater than 2. X is greater than 2 over 8. Or x is greater than 1/4. Over here, subtract 3 from both sides, and I get 8x is less than -8. Divide both sides by 8. That gives me x is less than -1. Okay, greater than 1/4, less than -1. So on a number line, -1, 1/4. What does it mean to be less than -1? That's this. What does it mean to be greater than 1/4? That's this. I see two intervals there. So the answer to this problem is -infinity to -1 joined with 1/4 to infinity. And there are parentheses around all of those. Okay. Next problem is, I have a polynomial graphed. Okay, so 2x to the 5th minus 10x cubed plus 8x greater than or equal to 0. List the zeros. Okay, so on my graph, here are the zeros. It looks like there are 1, 2, 3, 4, 5 of them. So the zeros are -2, 0. Okay, you have to list them as a point, xy coordinate. -1, 0. 0, 0. 1, 0. And 2, 0. Okay, those are all the zeros. Write your solution in interval notation. So the solution is, what is that asking for? That's asking for where the graph is greater than or equal to 0. So where am I, if this is my axis, where am I above the axis? Okay, so it looks like I'm going to have this from here to here, and then from here to here, and these are the areas of my graph where I'm greater than 0. So I have to write the solution in interval notation. So it's the x-axis. So I'm traveling along the x-axis, finding intervals, okay? So this graph is negative until it gets to -2. So it's asking for, remember, this greater than equal to. So this interval, the first interval that you see that's represented here, that's the interval from -2 to -1. And I have brackets, okay? Then the graph goes negative. Then it starts to go positive again. Remember, I'm traveling from left to right. As I go from -1, as I go from 0, over to 1, it's also greater than equal to 0, okay? And then lastly, remember, I'm traveling from left to right. When I get to 2, it stays negative for the rest of the trip along that axis. So that would be 2 to infinity, okay? That's where the graph is greater than 0, okay? Now, if I had asked for, and I'll just do that. Suppose I had asked for where is, let's just do this real quick, 2x to the 5th minus 10x cubed plus 8x, where it's strictly less than 0. Okay, so less than 0, I would be talking about this portion, and this portion. So on the x-axis, as I travel from left to right, that's going to be from -infinity to -2, parentheses, because I've got a strictly, it's strictly less than, okay? So the next interval is going to be from -1 to 0. And then the next interval is going to be from 1 to 2. That would be if I asked for where it's less than 0. One more polynomial here. So this one, let's get it to where I have a 0. So x to the 5th minus 3x to the 4th minus 5x cubed plus 15x squared minus 12 less than 0. So I'm looking for where is it below the x-axis. So where are my zeros? Here they are, what? -2, 0, -1, 0, 1, 0, and 2, 0. The solution. So where does the graph satisfy that condition? Where is it less than 0? So I see a piece here, and I see a piece here. What I have to tell is I need to find what is the x interval from there to there and the x interval from there to there that makes that happen. So it looks like, since it's strictly less than, strictly less than, I'm going to have parentheses. That first interval is from -2 to -1, and that second interval is from 1 to 2. Okay, and that is where I satisfy the graph being less than 0. Okay, that's it. So this last problem, 2.9, will not be considered for your quiz. That one we'll need to know by the end of the week for your unit test. I'll come back to this problem later, but this is all you need conceptually to get ready for the quiz we have. The other one thing that I want to make sure that you know is if you see a problem that looks like this, when you see absolute values and you have a negative sign here, don't just start working the problem. You got to bring some intelligence, okay? Absolute value of 2x plus 7, that is a positive number. -5, this is a negative number. What positive numbers are bigger than negative numbers? Every one of them. So this answer is all real numbers. Likewise, if you had something like this, 2x plus 7, absolute value, and you had less than -12, okay? Again, the clue is this negative number here. This is saying I have a positive number on the left side, and this is asking you for what positive numbers are less than negative numbers. There are none, okay? This problem has no solution, okay? So those are the two that you've got to recognize the solution and how to interpret the solution before you start going and working it and figuring out something that doesn't make sense, okay?